Hello students, today's video is titled Greatest Common Factor, and we shorten that by calling it GCF. So greatest common factor. Okay, in order to find a greatest common factor, we first have to know what a factor is. So I'd like to talk about that first. So here is the definition of factor. A factor of a number divides that number evenly with no remainder, okay? What is a factor? A factor of a number divides that number evenly with no remainder. Let's give you an example. The first example I have here is that we're going to find all the factors of 18, okay? So we have to think. Let's start with this one right here. Can you think of a number that divides 18 evenly with no remainder? Okay, well, hopefully you're thinking 2 because 18's even. 18 divided by 2 is 9, and 18 divided by 9 is 2. So both of these numbers are factors of 18. They both divide evenly. Okay, can you think of anything else? Let's see, any other numbers 18 can be divided by evenly? What about 3? 18 divided by 3 is 6, and 18 divided by 6 is 3. So 3 and 6 are factors of 18. Can we think of anything else? I have another 18 written here. Maybe 18 times 1, or 1 times 18. 18 divided by 1 is 18. 18 divided by 18 is 1. So these both would also be factors of 18. And I can't think of any others. I can't think of anything else that you can divide 18 by evenly. So that would be it. So these are all the factors of 18. But now we got to go a little bit further. What if I said, I want you to find the prime factors of 18. Now we're going a little deeper into the weeds here. So we have to know what prime means. So here's the definition of prime. A prime number is a whole number greater than 1 that cannot be exactly divided by any whole number other than itself and 1. Let me give you an example. 13 is a prime number. Here's why. It's whole, check. It's greater than 1, check. And it cannot be exactly divided by any whole number other than itself and 1. Like I can divide 13 by 13 and get 1. And I can divide 13 by 1 and get 13, but nothing else. Not 2, not 3, not 4, not 5, not 6, not 7, 8, 9, 10, 11, 12. That makes it prime. So like if 18 only had this set and these weren't here, then 18 would be prime. Okay. So let's see if we can find, and one other thing I want to mention, going back to this example, let me show you something really cool. If you take an 18, let's take it 3 times over again. So remember how the first set of factors we did were 2 and 9? Now, once you get there, 2 is a prime number because you could only break that down to 2 and 1. So I always circle prime. But the 9 can keep going. 9 can be divided by 3, and 9 divided by 3 is 3. In other words, 3 times 3 is 9. Each of these is prime because they're not divisible by anything other than themselves or 1. So if I was going to write 18 as a product of prime factors, I would write the 2 times the 3 times the 3. And watch. 2 times 3 is 6, and 6 times 3, back to 18. These are the prime factors of 18. But what's really cool is it doesn't matter which set of factors you start with. Like let's say we would have started back with 3 and 6 that we had chosen up top here. If we start with 3 and 6, right? 3 is prime, but 6 is not. So you would keep going. 6 can be divided by 3, and that would be 3 times 2. Those are prime. Now if you look, 3 times 3 times 2. That's also 18 because 3 times 3 is 9 and 9 times 2 takes you back to 18. So the commutative property of multiplication would say we can make this look like this or vice versa because order doesn't matter with multiplication. In each of these situations, we have 2 3s and 1 2, 2 3s and 1 2. And even if we use 1 and 18 here, if we would use 1 and 18, okay, 1, we would circle. And then 18, we could do 9 and 2, prime. And then we could do 3 and 3, prime, prime. And if we brought these down, if we did 1 times 3 times 3 times 2, we could say those are our prime factors. Notice 2 3s and a 2, just like these. Now, if you come over here, prime, a whole number greater than 1. So actually this 1 would be excluded from our primes. And I would actually exclude it up here. Even though it's a factor of 18, it's not a prime factor. So that even takes it further to making these look exactly the same. Okay, so if I wanted to quickly find the prime factors of 30, I don't have to do all these scenarios. I can just do one. Now that I know that no matter which way I go, I end up with the same prime factors, I can just go with whatever I feel like. So I start with the 30. What can 30 be divided by evenly? Well, 10 times 3. I could have done 15 times 2. I could have done 6 times 5. It's up to you. 3 is prime, so I'm going to circle it. But 10 can keep going. What can 10 be divided by? 2. 2 times 5. And 2 and 5 are both prime. So 30, written as a product of prime factors, would be 2 times 5 times 3. Those are the prime factors of 30. 2 times 5 is 10. 10 times 3 takes you back to 30. Okay, so what's this got to do with greatest common factor? Okay, so what is a greatest? We know what a factor is now. We know what a prime factor is now, but what's a greatest common factor? Here it says, when you consider two numbers, the greatest common factor of those numbers is the largest factor they have in common. So I know this says example 3, doesn't matter. Let's come down here. Find the greatest common factor of 10 and 15. So here's how I do it. First, you see this sort of Venn diagram. You have a circle and then another circle that overlaps the first circle. So here's what we're going to do. First, so step 1, put this here, step 1, we're going to find the prime factors of each number, which we just learned how to do. So let's do that over here. Let's start with a 10. Can you think of a number that divides 10 evenly with no remainder? Maybe you're thinking 2. And then, of course, 2 times 5 makes the 10. Both of these are prime, so we circle them. So on the left side of this circle, I'm not using the middle yet, just on this left side, I'm going to put 2 times 5, okay? Now let's work on 15. Can you think of a number? 15 divided by 3 would be even. So 3 times 5, those are both prime. So over here, I'm going to write 3 times 5. Now, step 2. Find the prime factor or factors. So I'll put an S in parentheses. The two numbers have in common. So if you look here, what do we have the same on both sides? Well, I hope you're thinking 5. So we're going to cross the 5 out here, and we're going to cross the 5 out here. That's what gets written in the middle. So the greatest common factor of 10 and 15 is 5. Simple. Okay, let's look at the next one. We have 2 more to go and the video will be done. How about this one? Find the greatest common factor of 12 and 16. Okay, let's start with the 12. 12 can be divided by 6. 6 times 2. 2 is prime. Break the 6 a little further. 6 can be divided by 2. 2 times 3. And those are both prime. Again, you're prime when you can't go any further. In other words, if you were breaking 2 down, right, with a caret, you would say 2 times 1. Nope, that's when you know you're prime. When your only option to go on is that number times 1, you're done. 1 is not prime, so we're just going to stop right there. So the 12 can be written as 2 times 3 times 2, and we'll bring that down here. 2 times 3 times 2. And you can check it. 2 times 3 is 6. 6 times 2 should take you back to 12, and it does. Let's do 16. Ooh, sorry about that. 16, let's see. 4 times 4. Could have done 8 times 2 also. Now, neither of those is prime, so we have to keep going. 4 can be 2 times 2. Those are both prime. And this 4 can be 2 times 2. Those are both prime. So as a product, 2 times 2 times 2 times 2. If you multiply those back, you're going to be right back at 16. So 2 times 2 times 2 times 2. Now, what do they have in common? What's in here that you also see in here? Well, I see a 2 and a 2. I don't see a 3, but I see another 2 and another 2. And so I would say, since we have 2 crossed off here and 2 2's crossed off here, 2 times 2 is 4. So 4 would be my GCF, or my greatest common factor. And that's how you do it. I hope that makes sense, and happy trails to you.